Yo, yo, yo. Today working on the meal tracker. The thing I really want to work on today is the fact that our async web server doesn't seem like async enough. In that, sometimes like writes fail. If we try to like handle a request and sending the response to that request takes up like more than one TCP window length. Um, this is actually like a big problem because on my phone, I actually can't load the debug WASM modules because they're like too big. Now, up until like 1 second ago, I thought that this was also the cause of these buttons not showing up. I figured like, because they used to be like X's here, and then one day they just stopped being X's, and I assumed that was because like my router firmware updated or like the Linux kernel updated and changed like TCP window sizes. But I'm not really seeing error messages here like I would expect to. So I guess maybe the first thing I'm going to do is try to figure out why these X's are broken, and then after that, fix async, which it might be the same thing. It might be the same thing. But I want to start here. I don't know why the fuck these X's aren't showing up. Can we do like a full refresh here? And can I look for everything? All. So delete SVG actually did respond correctly. So this looks like a different bug. This looks like a different bug, although I don't understand why it started showing up on the other version of this thing. Yeah, so this like drag handle as well as this delete button, they're both broken, right? So he's got delete SVG. If I change this to like /delete SVG, does that change anything? The JJ, thanks for the prime, much appreciated. No. So what's interesting to me is that like this delete SVG, if we look at this here, response does look like valid SVG if we just like navigate to this file. Can we oh, that's kind of interesting. That feels interesting. I feel like I used to see like a picture here. I feel like. Can we do this? Yeah, okay, so that is still there. I suspect this is a different problem. So I think I'm gonna ignore this for a second, because I thought that this was the same bug, which kind of like contributed to why I want to do this, but it's not the only reason. So let's focus the fuck up. We'll deal with that later. We'll deal with that later. The main thing, we need to find a repro for the web server falling the fuck over when I try to load big files. So if I go run the web server and open it from my phone really quick, you guys aren't going to be able to see anything, but it should be broken as fuck. Hold on. We should start to see an error here about it complaining. My phone's actually fucking stuck on LTE. It looks like my fucking router is maybe broken again. God damn it, this is a really annoying time for this to happen. Obtaining IP address, checking for internet access, and then he gives up. God damn it, dude. Signal strength excellent. That's really annoying. Okay, so we're gonna have to find a different way to reproduce this. Can we like... So I think the problem is that like when I curl from localhost, it like how do I say this? It works like too quickly. Hold on. So if I like try to look for like a big-ish file in here, hold on. Output dev null. Okay, see, like the problem here is he responds very quickly, and so I don't see like the problems that I would see due to like write buffering. Right? It would be interesting if I could like force slower localhost, you know? Force buffering curl localhost. Surely this is a thing that can be done, right? This is all people asking like I the other way. I want to make it happen. Let's ask the fucking idiot. Is there a way to force curl to buffer more on local host to simulate slower networks? Throttle. Yeah, that seems like a word to search. TC. Okay, so this is like, what is this? What does this look like? This looks like something that like changes parameters on an interface. Maybe it really depends on like what these are. What's this guy saying to do? He's like, I don't really want to do this. Curl with options, limit rate. That's more what I want. Should have started there. And this, I assume, is like in speed. Yeah. Shockingly, that's working too. I guess we need to like reduce the kernel buffer size, maybe? Right, probably what's happening here is the Linux kernel is accepting the whole write at once because it's on localhost. Interesting. Limit kernel TCP buffer size or something. Localhost buffer size doesn't look have like MTU 65536. Which is larger than like our thing is bigger than that though. I think that's I've seen that number before. Looks familiar, but um this C groups maybe you could sounds like a maybe option. I wonder if it's like when there's more memory pressure on my computer in general. This is again not what I want actually. When you look at these aren't no. This is talking about this shit where like the file system will like cache shit in memory. Localhost doesn't act like a real network device when it comes to buffering. Yeah, that's what I'm trying to like make it do though. I want like a fucking easy to reproduce case here, which it feels like should be able to be done. Dude, I fucking hate how much I struggle to Google now. Like, it's just so much easier to ask the idiot, which I hate. It does seem like TC might be the option, might be the right answer, huh? Might be. I don't think you can make it into a real network device, but surely I can limit the buffer sizes, right? Surely I can like simulate this problem. TC localhost queuing or something. No. So, like force blocking IO localhost. Dude, it's like, are you kidding me? What are the fuck? Like, obviously this isn't what I want, right? Like, what's the like? Okay, we need to get lower level. When am I returning would block? Let's look at. Where am I looking? Would block. So this is going for POSIX read would block comes from again. And then how are we setting up our sockets to be like non-blocking? Set non-block. Force non-block E again localhost. You can just use your own real IP instead of localhost. Is that true? Is that true? I kind of assumed that it would just still reroute through there. I assume, but maybe you're right. Server's not running. I assume that this would kind of behave the same way. At the very least... Ooh. Yeah, we're not seeing, like, the same problems here that I was seeing on my phone before. Which is annoying. Which is annoying. Interesting. Interesting. Oh, what if I do this? I guess this is gonna have the same problem where... Yeah, the throttling still is like happening in the browser, so everything's making it into the kernel still, which does not fix the problem. Okay, let's go back to what the idiot says. So he's like, this is not what I want, huh? Now we understand that the problem is different. We're like, slower is not good enough. Is there a way to force E again on non-blocking connections? On Linux. Okay, hold on. Wait, maybe we describe the problem to him and he can give us an answer. So like I have an async web server with non-block set on a file descriptor. When I write, I get E again when connecting remotely, and I cannot get a repro when working locally. Is there a way to reduce localhost buffer sizes such that I can test this locally? My usual trick is to bounce this traffic off a remote SSH server with port forward. Yeah, I mean, I guess that's like definitely an option. That's interesting. I'm interested in this. Buffer sizes. Yeah. Can we check that? Maybe that's the problem. Okay, so let's see here. When we get a new HTTP connection, let's just like check the buffer sizes real quick. Which I guess somewhere, who's like constructing HTTP connections? HTTP connection here. So here we get in a stream, and I guess here, can we just be like, get sock opt off inner handle. And what was this guy talking about? Alright, what's level here? Multiple protocol levels. Ah, I see. So this guy's saying, like... I see. So what are our options here? To manipulate sockets at the socket API level, use this, which is what that guy said. Okay. Okay, and then we have opt name. So we don't get a list of them in here? Do we trust him? I guess it's stood POSIX SO probably in here, and send buff. And what's the last thing here? I see the value and length, which in Zigland is probably a little bit more clean. It's just option. Okay. So send buff size. How do we know like the mappings of these things to types? Like, how do we know it'll come out of here? Man to get sock opt. Op name and any specified options are passed uninterpreted to the appropriate protocol module for interpretation. The include this guy contains definitions for different socket level options described below. Options and other protocol levels may vary. Okay, can we like open this? Most socket level. Oh, here we go. Utilize an int argument for opval. Okay, we trust him. Stood mem as bytes. Boom, boom, boom. Okay. Send buffer size is this. Like this. All right. That's annoying. Don't really want it to rebuild all of that every time, but whatever. Reached unreachable code. Invalid value. That's fun. Whoa, 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 whoa. Oh, maybe this thing needs to be, he's saying that it happens if the buffer size is wrong? Invalid happens if its length is invalid. Invalid value and opval. Interesting. So maybe the buffer size is like not allowed for localhost? That'd be kind of fun. Okay, hold on. What if we only serve on one IP? Yo, 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 yo. Still no good. Interesting. So am I crazy? I guess it is possible that this really is an invalid value. Okay, this guy's expecting level op name op. Level sol socket. Oh, hold on. Hold on. What does it say? Manipulate the options at any other level. The protocol number is the protocol number of the appropriate protocol controlling the option is supplied. For example, to indicate that an option is to be interpreted by the TCP protocol, level should be set to the protocol number of TCP. See, get proto-ent. Reads the next entry from protocol's database. Whoa, 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 whoa. What the fuck does this mean? Get proto reads the next entry from the protocol's database. See protocols. Okay. Protocols definition file. Okay, so like etc protocols. Okay. So we have like 6. Okay, so then what the fuck is this then? Socket is 1. So if we like ICMP, it says 1 here. So I'm confused. Right. Maybe this guy's like a fucking liar. Set or get sock opt buffer size. That's not what I'm looking for. Uh, is this just like fucking? Do I care? Yeah, who fucking gives a shit? Who fucking gives a shit? Uh, I mean, that is what this guy's saying too, right? Weird. Maybe, I mean, is send buffer different than receive buffer? I assume not, but maybe. How strange. Okay. Uh, I wish my phone wasn't fucking kicked off the network. Because I don't really have anywhere where I can, like, try this from a different device to see if this is different. Like, if localhost just is, like, for some fucking reason different here. Do we just fucking drop all the way to, like, Sealand? Because this is surprising to me. This is surprising. Is it possible that handle here is wrong? Socket T, level, socket, op name, opt. Man, get sock opt. Maybe we're not allowed to get it. Wait, man 2 gets sock opt? These are different than man 3 gets sock opt? That's interesting. I mean, they're basically the same though. Who thought that just showing the fucking problem would be this hard? But like, we can't make a fix until we have like a thing that we can use to test, so it's worth looking into. Worth looking into. Okay. Let's try going a little higher up. So when do we call set non-block? When we get a new TCP connection, somewhere we go, hey, let's fucking set that thing as non-blocking. Okay. So can we, like... Can we just put the same thing here for a second? I'm assuming this is the same shit, but I just want to move some shit. I just want to, like, you know, let's just try some stuff, you know? I don't know. Yeah, so exactly the same problem. So what is this guy calling? He's calling system get sock opt, which we will note is different if we're linking or not linking libc. Okay? So that's interesting. For sure. Are we linking libc? Because if we are, then we are calling libc's get sock opt. Okay? Which is man 3. You're trying to test blocking rights. That's difficult because they're really rare. But the thing is, they were fucking happening to me. They were happening to me, and that was pissing me off. I was seeing it when I fucking opened from my phone. It's just my fucking router's broken, and so like sometimes I can't like show you the problem because my phone's stuck on LTE right now, which is fucking annoying. Okay. To retrieve options at the socket level, specify level is socket. To retrieve options at other levels, okay, cool. Okay, so e-access if we do not have appropriate privileges. E-inval if the socket has been shut down. E-inval if the specified option is invalid at the current socket level. Okay, so can we look at like what are our options for like we need to look at syssocket.h. That's what we gotta do. To figure out like maybe what's valid and what's not valid. You know? This is OpenBSD stuff, but can we try like asking for something fucking else? Also, how do we know like the type of the return? Integral values. So let's ask for like SO type. Is that a thing that we can ask for? Surely, right? Okay. Even that. Okay, so that's interesting. Interesting. Optlen invalid in set sockopt. Okay. Oh, but this is in get sockopt, which is interesting. Okay. In some cases, this error can also occur for an invalid value in optval. Where optval is... Oh, wait a second. Socket level name. Optval is literally just like a fucking pointer, no? Or, and length. Pointer, length. Pointer, length. So, like, seems like we can't be fucking that up, no? We're looking for a pointer to an array of bytes, of like a void, I guess a void pointer, with some length. And he's like, it's invalid. Why the fuck? I don't really want to demessage on screen. I'm not really sure if that's going to leak something important. So I'm just going to like quickly SSH into my other account and demessage off screen. Just to double check if there's anything interesting happening in there. I don't think there is, but just in case. Oh yeah, I'm seeing literally nothing. Literally nothing. That's so interesting. Okay, let's at least prevent ourselves from crashing. It's possible that like, it's possible that we're like closing a connection, like there's like two connections opening and like then we're like shutting something down too early and that's causing problems. I guess that doesn't seem very likely. Doesn't seem that likely. But like, yeah, it's very, or can we yeah, it's fine. It's fine. Let's go down a level. Okay. So this is all the same. And then it's just that we have, this becomes like a pointer cast. of send buff size. And we need 4 here, I guess. The length of that thing. Okay. And then can we print the return value here? Just like for feels, you know? And then can we, I think that this is gonna like be a bit cast of like, I think this is how this works. Where the syscall will return a usize. But we need to like convert that into a signed integer to like error to see if it's negative for error checking, I think. That's my recollection of how this stuff works. Whoa. Optlen is a socklen T. Pointer? Oh. So this will probably also tell us how long the output actually was or something. Let's see. Let's see. Send buffer size 0, 1, 4. So return value is 0. Send buffer size is 1. Outlength is 4. Dude, this is confusing too. Because I would have assumed that when we called get sockopt here, we're getting like error no here, no? Oh, but he's saying use libc. So like here we're dodging the libc API, which is behaving differently. Also, the fucking oh, this is type, not send buffer. Oh wait. This is good. So now we can actually look at the send buffer size. If we just fucking I don't know why the libc API is fucking broken there. But this is good. There we go, baby. Okay, so that's really interesting. I don't know why the fuck the libc API here is fucking broken. But this is at least promising. Okay. Okay, we're getting somewhere. So can we set sockopt here? Have we finished the barcode yet? No. This is blocking some other stuff that I need to fix. So we're taking a slight detour. I have ideas for the barcode. We'll probably get back on it tomorrow. Probably. I'm actually I'm planning on getting down like an uber big rabbit hole. I want to finish the current like train of investigation on the barcode first, but I think it's likely that I want to write a machine learning framework to compare a machine learned version of the barcode parser versus what we hand write for like speed and accuracy. And to do that, I think I'm going to have to do like GPU like vector math stuff, which means that I'll probably want to learn Vulkan before, so that I'm not like hacking with OpenGL. So a big stack is coming that it's like food tracker, barcode, machine learning framework, Vulkan, and then to learn Vulkan, we're probably gonna write like a ray tracer or something, you know? So we're gonna get like we're gonna get real deep in it, is my current plan. We'll see what happens, but that's kind of what I'm thinking right now. Okay, so set sockopt. So to be healthy, you gotta learn Vulkan. Got it. Yeah, exactly. He gets it. So to set, it's just like the same shit. With opt val. Yeah, it's just the same thing without the pointer. So can we change this to like, you know, I don't know, 16 pit K. What's he about here? Yeah, true. So true right now. Okay. That's a good sign. So it's kind of funny that we resized to 16K and sometimes it's just like, nah. But look, we fucking reproed. We fucking reproed, baby. So now what's happening is we're failing to load WASM files, which is what I was seeing on my phone. That like we can't load some of our big WASM files because we would block. So hell yeah. So somewhere was like intro. I don't know, man. Find repo row at some point. And this is ready. Okay. All right. Now we can finally start looking at finding an answer to this problem. I guess we can kind of do this. Boom. All right. So, what is actually happening here? You know, now that we've fucking found a repro to our problem, we can actually try to show what the problem is. So, the way our thing works, let's see, main maybe, we start up a server somewhere. We create an event loop, stud event loop initialize. We register a server handler, which is what? Like a server, which comes from EventNet, which is probably just like a TCP server. With a connection generator, right? So every time we get like a new connection, we call into this guy who generates HTTP connections, I assume. Yeah, he returns HTTP connections. So we have an event loop that is backed by epoll, which is basically like, okay, how do we explain this? I want to respond to like many connections at once, right? So I'm going to have like a file descriptor. I'm going to call like something analogous to, you know, let's do, you know, set file type equals C. You're going to do something that's like, you know, I have some file descriptor that's like some TCP listener, right? So like some socket that is waiting for new TCP connections, right? And you're going to be like, while read file descriptor, like get new, just like handle new connection, right? So what you could do here is like this, like, there's something wrong here. It's like accept actually, or like something like this. And it's like more like, you know, probably more along the lines of like, while true, like int ret equals accept file descriptor connection, you know, probably something like this. I don't really remember the API here. If ret is less than 0, return -1, something, you know, whatever. But you're going to have like some connection, right? And you're going to then, in the simple case, be like read from connection, right, into some buffer, and then like parse HTTP request, and then like write connection response, right? Something like this. But in this like simple case, right, you're kind of fucked because if like these are like blocking calls, right? So this could take like a really long time if like the person you're talking to is really far away. And in this version of the loop, nothing can fucking happen. You can't talk to anybody else because like everyone else is waiting here. Right? Boo. Gross. Nasty. So there are like things that you can do to like fix this, right? The like super simple solution is do this on its own thread, right? Which like works. Every connection gets its own thread, but that has problems where like the scaling is kind of bad. Every thread gets like an 8 megabyte stack. You have to rely on like kernel context switching. You can't like prioritize connections yourself. There's all sorts of reasons why like that's like not ideal. It's slower, right? context switching is like expensive, all of that stuff. So there are interfaces to say like, pull many connections, please, right? So the like basic version of this is that you say like, I have like a list of file descriptors, something like this. We're skimming over details. We're skimming over details, right? But you're gonna have like, you know, A, B, C, D, and then when you like accept this connection, you're gonna be like FDs append. We're getting like farther and farther from C the longer we're talking. But you know, you do like yeah, append vec, fine, like FD's connection or something, right? You would do something like this, and then you have like a list of these guys, and you can call pull on like all these FDs, right? Something like that. And this will say like on like when any of these guys have data, like unblock, right? So this will just kind of like sit here until any of the file descriptors you have some data. Now this interface kind of sucks because like, oh, there's also another guy called select, which is very similar. They're both like POSIX APIs that are like say pick from many of like a bunch of these guys, and these interfaces are not like the best. I think if I remember correctly, some of them you have to like iterate all of the every file script you put in. So if you have like thousands of them, you have to like iterate thousands to check if they're right. Some of them are not like that, but I think they're still slower. I think like the POSIX API standard like forces some inefficiencies there. So along comes on Linux this thing called like epoll, which is like the same concept, except instead of like passing in a list of FDs, you have like my like epoll file descriptor. You know, you like epoll make whatever, epoll create one. I think the function is actually epoll create one, something like this. And then what you do here is when you accept new connections, you just say like epoll like something, but like modify like watch this fucking file descriptor with connection, right? And what this guy will do is like, it's basically the same thing. You'll call like epoll wait on your epoll file descriptor, and he's going to return like what the fuck happened, right? It's funny to accidentally capitalize fuck every time, you know? But then you can like look at what the fuck happened and respond to those things on those file descriptors, like read and write at that point, right? So that's like essentially what we have here in our event thing is on initialization, we call epoll create one. Everybody registers themselves with this guy, right? So this is like some handler comes in with like a like a vtable that he's going to like, you know, that has a function pull on him, as well as a file descriptor, which is like the thing that we're registering with epoll. So this is going to be like the TCP connection for the new guy, right? So this basically says, hey, epoll, like, take this file descriptor, and also like here is the interface I want you to call or to give me back when I'm done. Then when we call wait, we say like, hey, let's like get the data associated with this request and just like fucking call this guy's pull function, right? So this is very like, how do I say this? It's inspired by like Rust's async API a little bit, not the async like keyword part, but the like idea of you have some state machine, you just poke it. Every time the file descriptor says like, hey, there might be data here, we're like, okay, let's look at the data. So that's like kind of like the lowest level API. It's like a, you know, event loop setup. We have epoll, we have a vtable with pull and close functions. But one level above that, we have HTTP connection, which I don't remember what it does, but we can take a look. So I assume HTTP connection, like, he implements pull and close, right? So on pull, we do what? We like try to read some HTTP stuff, right? So from like the TCP connection, we go like, hey, here is some data. Looks like we say, hey, if the connection is, if we saw like the HTTP header said that there's going to be like 10 bytes and we've read like 10 bytes, that means that we're like fucking ready to go, and we will call some other function, self context serve. And this is the problem. This is the problem, is that like this is like a very blocking style API, which is wrong. Right? So we call self CTX serve, and that is where like in main, this is where all of our like actual stuff happens, right? So like in our meal tracker, we like parse the request and we have all of these like options. Like they said add a meal. And so we're going to like go into our database, we're going to add a meal, and then we're going to respond with some JSON, right? Hype. Now what's probably happening here is one of the things that we can ask for is some WASM file, right? And here we like read the whole file into memory, which is like fucking stupid. We shouldn't do that. Problems. On serve read whole file into memory. Like the fuck? We can just pipe one FD into another, right? That's one problem. Another problem. Hold on. Let's try to make some space here. I guess we can just get a little smaller too. Other problem is that like writing assumes blocking writes will work, which is not true either. Right? So really like this guy needs some sort of like poll function, probably. And this guy is going to have like, okay, we need a picture. We need a picture. So it is, we have some like HTTP connection, and he's got this context. This thing is polled every once in a while by the event loop. Event loop calls poll on this guy. Now, what did we say? He like buffers, he parses HTTP shit. Right? That's his job. And then eventually calls into CTX. Then calls into the context that we provide him, our like application specific HTTP connection context. Now, this guy needs to what? He needs to like either return something pollable, return like epoll friendly writer. That's an option. Or we could like, the other option is that he's like polled himself. Yeah. So like, what are those two options? It's like, both of those are fine, I think. I think both are fine. So in this version of something, this like HTTP connection lives for longer, and he goes from like read state to write state, probably, right? He says like, it turns into like, hold on. This turns into like here, where we finish parsing the HTTP header. Instead of being like, we're fucking donezo here, this would be like, move into write state, and then like, poll HTTP, poll writer until ready to go. Or another option here is, we like, move into write state, we still return complete, and register writer with event loop. That's another option. Not sure. Sorry, I don't think I ever answered your question when you're like, just did we do an HTTP server from scratch? Yes, we're fixing it. Fixing one that already exists. I think I just forgot to answer that. I think this might be... Some of this doesn't feel ideal. Why? Because our HTTP connection, I think, someone assumes they have, like... Someone has, like, an allocator that they read stuff into. Who owns that? This guy. So the HTTP connection, who is like the generic type, he has like an allocator that he uses to read the HTTP request into. I see. And so like, if we nuke him, then the request is gone. Which we might not want. We might want him to stay around for a while. So I think... My gut says that it's nice to have like one connection here, and that the maximum flexibility is if we support polling, or like even not even support, like mandate polling on the like application specific context that we pass in. So this like function that was previously saying like, yo, we fucking finished we finished reading the request, now fucking serve the response. This should turn into like... I wonder if like... Hold on. Who initializes this guy? He's initialized externally. The application initializes this guy and feeds him into the HTTP connection as a context, probably. Probably. It's gotta be, right? Oh! That's interesting. I see. So there's like... Whoa. Shared? Oh, so this context is actually not part of the connection. This is like one global context to rule them all. Then on serve, this is where we like, you know, connection specific stuff happens here. Interesting. Which I think is wrong. Right? If we want this guy to be able to like hold state and like, you know, serve like 1/4 of a file right now and 1/4 of a file later, he needs like specific state. I guess I like the idea too of him just like returning some interface. So like most of the guys could just be like, you know, buff writer, right? And he's got like, you know, data in here and like how much has been served, right? And then like this guy's like polled, you know, with some like poll results, whatever. There's like something nice here. And then like if we want like pipe writer, you know, he's got like file descriptor 1, like, or like in file descriptor, and like out file descriptor. Then like his poll can just like, you know, read some shit from here into there, send file. Yeah, I guess that's... Is that the right answer? Yeah. Yeah. Yeah, so this guy calls like, you know, pipe writer poll result. He calls like send file. You know what I mean? There's like something nice here. And then if we just like return these from serve, maybe that's fine. you know, if these both like implement some sort of like HTTP, it's not. This isn't even HTTP specific, actually, right? This is like, this is literally just like put data into fucking file descriptor, which is pretty generic, and like that's almost what the existing interface is to the event loop. To be honest, right? We already have this like handler thing, who is just like, I have some file descriptor. Yeah, it's very close to this. So the only difference here is that like we don't need to own our own file descriptor here, because we don't have to bind to the event loop, because the HTTP connection will like own this shit. Okay, I think we're getting somewhere. So here's what I'm thinking. I'm thinking that we have like state here in the HTTP connection, the general HTTP connection. And here we can be like reading and writing, right? That's kind of it. And his initial stage is reading, right? And if we are writing, we have like our right, like, it's almost like we just have handler again. Here's what we'll do. So our handler right now, somewhere we just want like the same interface just without close, I think. Even I don't think we need to close. No, we do, because we're gonna have like, if our writer allocates something, he needs to be able to free it if he wants. So it's literally just the same thing, just without the file descriptor. So like, I'm thinking that there needs to be some sort of type here that like is meant to be like handler, but not registered directly with epoll, like meant to be used as helper abstraction in other handlers. You know what I mean? Like nested writers. Like e.g. HTTP connection holds something that is pulled in stage 1 and something else pulled in stage 2. You know what I mean? You know what I mean? And I feel like this living in the event loop library is like a reasonable thing, and almost should be used like here, right? It's almost like a handler turns into this guy, and then like we have like loop handler is handler. You know what I mean? Yeah. Yeah. And then this guy gets like loop handlers here, and then like everything that used to be handler is loop handler. Yeah. There's something there. There's something there. Signal handler. But this interface was nice. I guess we can just do this. Yeah, that works. Loop handler is like handler, and this guy gets handlers here. Yeah. I can definitely say I don't know what you're talking about. That's a good point. That's a good point. So we kind of have, the thing I'm trying to disambiguate here is thing that can be polled to make progress on some async action. This is handler. Then we have a thing that can be registered on event loop. This thing obviously, like, he needs a thing that can be pulled, so the handler, and he also needs a file descriptor. That's kind of like the distinction I'm trying to make. So that's where like loop handler versus handler is coming in now. And then yeah. You know? Where the fuck did this come from? Must have just hit paste by mistake somewhere. This stuff is obviously not ready to go yet. I fucking just pressed a button there for some fucking reason. That's funny. Okay. So we need to rename places where this like nested handler is happening now. It's funny. Handler.handler. Maybe a bad name, but whatever. So here we've got like a nested thing now. Are you re-implementing the new IO interface? Yeah, probably. Like by some metric. What's he complaining about? He's complaining about this guy not returning a loop handler. Okay. Something like that. Is that stuff in main yet? Thought it was working previously. Yeah, I'm not a fan of using stuff that's not released. So I'm like totally happy to like change this later. Or we don't even need to use our own IO interface if we don't want to. You know what I mean? Like we have the choice to not do that if it's if the cost is too large, you know? Also want to thank you for the TDF parser. I got a working Z menu, which likely doesn't exist already. Hell yeah, dude. Hell yeah. Okay, so this compiles now. And so now we should be able to say that our serve function, our context serve, this guy is now expecting to return some sort of like handler. That's the new answer here. That's the new answer. So let's implement. Implement fix. Yeah, and this might also like fix big reads as well, because we can make it so that big reads use send file. I think we can do both of these at once. I think. Okay. So our serve function, this now returns a handler, not a loop handler, just a normal handler. And I guess that means that like respond JSON should also create some sort of handler. Which we will figure out soon. I guess we want to keep compiling, I think. So let's just start here. Let's comment out all of our fucking handlers. Everything we do is now done. Else, return error unimplemented. Okay? Cool. Cool. I guess this won't fix big reads because big reads, this function won't be called until the body is finished reading. So we might have to fix that. We might have to fix that later. We'll start with the right stuff first. Okay. So this guy needs to return a handler and switch his state. So let's call this poll read. Oops. Everything we were doing before is now just the read state. And if we are in reading, we call poll read, right? If we're in writing, we try poll write. Sure. Easy. Which means that now we need a poll write. And this guy has like his handler. Okay. So then we can have like writing has handler with this. Okay. Cool. So now we just have to be like, handler is this. We say self state is writing is equal to handler. Okay. Cool. Needs to be a handler as well, but we'll get there. We'll get there. And then we just call like poll write with the handler, I think. Cool. What's he mad about? There's already a handler. Where? Oh, it's a function here. Sure. Inner handler, I guess. If inner handler poll. Ooh, poll takes in a loop, which it doesn't need. Yep, okay, so renaming this type was wrong. We should call this like a pollable or something. Yeah, I don't know. I don't know what like the right name for this thing is. Because this thing doesn't need to take in an event loop. That's stupid for this interface. So we just need like other handler, like handler helper. Maybe is a better name for what I'm asking for here. So, something that can be like part of some handler that is pollable. Maybe we just call it pollable. I don't know, man. Pollable? Maybe that's the answer here. So this guy's like, again, he doesn't need to register himself with the event loop, as far as I'm concerned. As far as I'm concerned, so the vtable looks a little different. Yeah. Sure, and maybe finish is a better name for this. Or like D in it, even. Okay, sure. Sure, so something like that. Pollable. So now this guy returns a pollable, and bing, bang, boom. We call poll on this guy with no arguments. And we switch on this guy. Okay. If he's complete, we return complete. And if he's in progress, return in progress. Which means we can probably just return this thing. Okay. Not sure if we're going to need to do more here, but we will see. And then here on finish, we say like if, I guess it's like switch self state. And if we are in the writing state, then we have like, we have to finish this guy. Okay, there we go. We're getting somewhere. We're getting somewhere for sure. Okay, so our context now is not returning this. He's returning a pollable. And then this poll function needs to take in a pollable here and here. Okay. We're definitely getting somewhere. What is this guy mad about? Value of type poll result ignored. Oh, sure. We need to return it. Chillin', dude. Dean is a bad name. I will down this hill, but it is the opposite of init. You know? Which I'm okay with. But yeah, I can see the argument. Okay, so all of this looks like somewhat reasonable. Somewhat reasonable. So now we just have to actually do it. Right? So here, let's start by doing like, you know, one of many. Right? So we like do a thing and we have some JSON to respond with, right? I think here, what are we working with here? We have some like scratch space that we put our response into. And then we like just huck that shit into the connection, which is no longer what we want to do. It's no longer what we want to do. We want like this string to live for some like long amount of time, right? So I almost feel like this guy gets an allocator that is like the connection allocator. You know, things that we want to live for the lifetime of this connection. And I almost feel like in respond JSON, we use that allocator here. Right? This is going to be sketchy though. Because it will be easy for us while we're converting to keep using like an allocator that will go away. But maybe that's okay. Maybe that's okay. So this guy's gonna return like a, you know, like pollable, right? And it feels like having like, you know, who owns the concept of like some buffer that you're piping into some file descriptor? It feels like it should go here. You know, like buff, like I want to say buff writer, but that means something else. Like something where we're writing some buffer into a file descriptor. Maybe like this. So he's got like a file descriptor, which comes from like OS handle. Sure. And buff. Right? And position. And his poll function is like, he goes like, if index is equal to bufflen, we're done. Right? Seems reasonable. Okay. Seems reasonable. And then otherwise we're like we in a loop try to write into this thing. Why is file descriptor? Oh, it's a std POSIX write into the file descriptor. I guess this thing has to be failable, no? If we're planning on like writing into this thing. I guess, yeah. I'm down with the pollable interface, allowing errors here. I'm down with that, to be honest. And then here, yeah. Because this is meant to be like a helper for other guys. So like just letting errors bubble up here is like kind of fine. So we do a write here into the file descriptor with, you know, self buff from self index onwards. This is going to tell us like how much it wrote. And then I think there's like if amount written is equal 0. I think that this is done. Blah 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 blah. If count is 0, if count is 0, oh, that's here. Okay, if count is 0, blah blah blah. On success, the number of bytes written returned. On error, -1 is returned. So note that we may transfer fewer than count bytes. Such partial writes can occur for various reasons. Yep, of course. Blah blah blah. I was under the impression that 0 means like we're donezo. But I guess maybe not. Maybe that's on read. Maybe that's on read 0 is special. So I think we're chilling here, but this guy, yeah, we're chilling here. And then this should be actually greater than or equal here. And then in reality, this should be part of the while loop. And then if this thing fails, we check if it's would block. Right? I think that's what comes in here. Whoa. Oh, that's WASI. Yeah, would block. So if this is would block, we just return in progress here. We're not done. Otherwise, we return the error. Is any error actual keyword? Yeah, it's for like, if there's sometimes where the compiler can't auto-resolve the type. And so any error is like, I think it's a special type that says like, at runtime, this type there is figured out, I think, but I'm not entirely sure. I know it helps in cases where the error set that could be returned cannot be easily identified by the compiler. This seems pretty reasonable. Global error set, which is basically a Kotsuminem. Ah, I see. But I was under the impression that, oh, sure, okay. So all errors for all functions go into the global error set, and then the compiler takes subsets of that error set and uses those for like type checking. And then in the cases where it can't figure out what the scoped set is, you write any error. I guess, is that the answer? Maybe it's something like that. Okay. So this seems, I guess this is like FD buff writer. I guess that's like a good name for this, right? We're taking a buffer and running it to a file descriptor. What else more could you want from this? And then our close function, file descriptor ref buff writer. Right? So like this is like not owned. No owned fields. You know? You know, so that on close, we just do this. And then we have our vtable here is a pollable vtable where poll is poll and close is close. Wow, we're getting crazy out here. Crazy! Okay. Yeah, I think this is fine. I'm actually a little confused here for a second. We'll see. It'll kind of clear itself up, though. So this is like this. Pointer is self, of course. And vtable is vtable. Okay. And then that means that like this thing has to live somewhere, right? So if we, as part of the HTTP connection interface, want to return the interface, then like the concrete version of this interface needs to live somewhere that will like live forever. Which is fine. That's not that bad. Because we can say that on the connection allocator, we can create a fd buff ref writer or whatever. And then this guy lives on the scratch allocator for a second. Ooh. Interesting. So here we actually have like previous implementation of this thing did like 3 writes, right? One was the like HTTP header. One was, and then I guess it's 2 writes. Then we wrote like the JSON body, right? And this was like, his own allocation, right? Which is not really ideal here. More ideal if we could get everything into the same output buffer. Fairfire, thanks for the prime. My favorite vibe coder, hell yeah. We're vibing for sure. We definitely vibe and code. So I guess that's fine though, because we can just call stringify. I assume that there's some stringify into writer. Outstream, yeah. Okay, so that's close. Right? Hold on. So, HTTP writer. What is this guy? He says, go into any fucking writer you fucking want. Go anywhere. Okay. So this guy's just writing into the writer interface. Can we just say like start body? Yeah. So then we go like, we write our header. We start the body here. We say we're ready to fucking go. And then we put this into the writer. Okay, yeah. So the output buffer. Oh, but we need to know the length of the JSON first. That's why we did it this way. True. We need to know how long the response is. What? What? Okay, so like maybe what we actually want here is like multiple buffers written. That might be easier to structure this way. So here we allocate the JSON response, then allocate the HTTP header, then write HTTP header, write JSON response. It might be nicest to kind of structure this way. Because then we only have to like generate the JSON string one time. We can put it in some memory location that will live for the lifetime of the connection. Create the header. Yeah, that's not crazy. And then that means that this like HTTP writer thing almost doesn't need to exist. We can almost just like okay. It's almost like we have some function that's like make HTTP header. And he takes in these parameters. I guess they're actually very slightly different. Because we need all headers to be here like fucking now. You know, yeah, so there's like something like this. Yeah. Yeah. And this is just gonna be like a buffer that we can fucking slam out there. Yeah, that feels pretty good. Now, how do we know the length of the output? So, like, outlen is, you know, oof. Oof. So, we need to, like, calculate the length ahead of time, I guess, if we don't want to, like, over-allocate. Maybe over-allocating is fine, but, like, maybe this is easy. This is, like, calc serialized length or something. Ew. Not trivial. Not trivial. I guess we could, what do they do on print? What do they do in the format library? Count format args. So they do a nullable counting writer. I see. That's interesting. So they just like write the fucking string twice, once to nowhere, just counting, and then once to the actual output. Interesting. So we could kind of do the same scheme here. It's not super crazy. Right? So you have like, you know, um where we basically do all of this stuff. Whatever we were doing before. So we like try to append header. Which now brings us back to this guy, I guess. Yeah, that's funny. Yeah. Interesting. I feel like we might be running circles around ourselves. Haven't quite figured it out yet. We'll see. uh, yeah, so I guess we just do like start, and we just kind of pass this shit along. We'll see if this becomes like stupid later, right? But we'll just go where the heart takes us, and then eventually we might end up somewhere. Maybe it'll end up looking okay though. I don't know. Then we like do append header with header key, header value, and then we like start the body, right? Right? That seems reasonable. So we're like, make a HTTP header with this thing. Then here we go like, counting writer is stood IO null writer, stood IO counting writer with a null writer behind him. And then we're just like, fucking slap this shit in here. And then we have like bytes written, and we can use that as an allocation. Okay, yeah, and then we can go like, you know, var fix buffer writer. Yeah. I think this is right. Right? So we use this existing HTTP writer to like do this in one shot. And we say like fucking run it once, count, then do it again. Here's the output. Yeah. And then in main, now we can be like, here's our response body. We can say like, make HTTP header with our connection allocator. He will only allocate the amount that needs to. And then we kind of do all this shit once. So status is equal to okay. Content length is equal to response body len. Yeah. Huge. And is that it? Yeah. This we can just default initialize to empty, the extra headers shit. That'll come up later, I'm sure, but for now, that seems okay. Right? Right? Okay, so now... This might be buffs writer now? Okay. Right? Right, that's not crazy. That's not crazy. And then our file def buff, fdref buffs writer, we just pass in two buffers here. And so here we say like if self buff index is greater than or equal to self buff buffs len, return complete. Okay. If our self char index is greater than self buffs itself buff index length, we say self buff index plus equals 1, you know, and the char index is back to 0, and continue loop again. Okay. Now here we're looking at buffs at buff index from char index onwards. Okay. And then we increment the char index by this much. Pretty fucking sick. Now, here in reality, we should be using like pewrite, I think is the call for this. Where we can PV write maybe? There's like something where you can like do multiple buffer writes in one syscall. Write multiple buffers, one Linux syscall. No self promo. Delete. Sorry, man. There's some fucking function that you can call that writes to write v, vectored write probably. Yeah. So here you can say write multiple buffers at once, which is more efficient. P write v. I don't remember what the difference between this and this are. But I think this is the right answer to this problem. Oh, with offsets. Yeah, I see. Okay, but for now, we just ignore that. Okay. So, we try to create our header and body, and then we create our buffs writer. My bad, no worries. No worries. And here we set our FD is the connection handle. Okay, that's easy. What else goes in here? Buffs. So the buffs is just like header and response body. Okay. And then this guy we return like ret holeable. The interface for this guy. The generic interface, which means that this has to be public. Okay. That seems pretty good. That seems maybe reasonable. Okay. So now this guy's mad about something. We need to pass in our allocator to this guy now. So the connection allocator is self alloc. We'll pass him an arena. Whoa, what's he pissed about? What's he pissed about? Expected type pointer to this stuff, blah, 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 found const HTTP writer. Okay, true. Probably. Oh, this guy wants var here, not const, I see. Oh, and this thing can fail, I see. Oh, which means that the one below can probably fail as well. There we go. What was that guy pissed about? Return here. Close here. Yeah, we call this finish, actually. Okay. Okay. I mean, that doesn't seem crazy. That, like, might work. It might. Okay, so I guess, how do we test this? We just curl here directly. It's So we just try calling add ingredient with a name. So we go curl localhost at 9990 add ingredient. Unimplemented. That's surprising because add ingredient. Oh, is this? Hold on. Oh, it's ingredients. It's a put on ingredients. My bad. So this should be x put with ingredients, and then like name. How does JSON work? You know, something like this. Okay, so he's pissed. Why? Because on right we got e fault. That's crazy. That's crazy. Buff is outside your addressable address space. Okay, so we're fucking something up for sure. It's good that we're testing. Uh, okay. Oh, I see. I have to do a new name now. Okay. So what's going on here? So looks like we have a buffer of length 2, file descriptor 9. Okay. This is broken for sure. So the thing that we returned here seems to be wrong. But I don't really understand how. So we say, like, it looks like this is busted. Oh, because this is a fucking slice. And this is pointing to the stack, and then the stack gets, like, fucking nuked here. That's really easy to fuck up. Really easy to fuck up. So maybe we do it like this. I mean, this could also be like a side, like a proper array, but I think it's better to do this way. Um, uh, yeah, it's just so easy to fuck it up that I think the interface forcing us to allocate makes sense. Yeah. Okay. Um, okay. Yeah, that's fair. Fine by me. Is running your own web server part of the food project? Yeah, basically. Yeah, it's related. Okay. So now this goes to like FD buffs writer initialized with allocator FD, and then we can do this. There we go. Okay. What's he pissed about now? My, like, dupe is bad? Why? I'm like, the slice, it's a list of strings, not a list of strings. Cool. Okay. So now, hello 3? Nice, dude! Okay, that's really good. So we got like a valid response here. Which to me indicates that this is at least like not super fucking stupid. Which is good. Okay. Respond empty, I guess. What we can actually do here is we can have like a constant like empty buff. Empty response. I wonder if we can get like this thing as like you could almost get this as a pollable. Yeah, this is there's something here. Make empty response. Cuz like every single one of these is going to be exactly the same. Okay. So here we just have our uh hold on. FD buffs writer is we kind of manually make this thing intentionally. Fuck, we can't do this. We can't do it this way. We can't have it be constant. This guy is going to take in, I guess, a connection to make this guy out of. Yeah. Okay. It's fine, it's fine. We can at least do that the response is a comp time block here of even this doesn't work because the interface forces an allocator. But surely, like, surely we don't have to allocate this every time, right? Surely. I wonder if you can, like, is there like a comp time allocator? That might be like a stupid fucking question. But it feels like you could like generate this with the allocator interface at comp time, but maybe it's just too complicated because it goes through like runtime interfaces and shit. Yeah, there's like comp time print, which calls buff print with count to format args. Yeah, I see what's happening. Where count is actually using the counting writer. Oh, wait, maybe. Wait, that's like a maybe. We saw barcodes, we're taking a break. Just a slight break. Because this is like a thing that's bothering me every day. And I need to fix this. So you could do like how it's like we expose the count here. HTTP header len with params of HTTP header params. Yeah. And then this stuff goes here. Okay. Not that any of this matters, but it's kind of fun to do it this way. Okay, so we have like a var buff is a stud HTTP length of, I guess we have like params, like header params is a HTTP header params with status is okay and content length is 0. Okay. Then we should be able to be like, let's fucking get the header length of this thing. Then can you use like can we just do like you know stud me or io fixed buffer writer and then use that here? Does this work? Be kind of hype. That would be kind of hype. Because then you could just copy it in here. Uh, um, you know, that'd be kind of cool. Let's look for somebody that responds empty. So like modify ingredient, he responds JSON. We have like delete meal, I guess. This returns a pollable now. All right, let's see if that works. Expected use size found. Oh, sure, try. True. What's going on here? Yo, thanks for the raid, much appreciated. You work on a barcode scanner, I believe. How's it going? It's going okay. I think that we've overcomplicated it for ourselves. Well, that's okay. We're taking a slight break for today, which is okay as well. Which is okay as well. Right now we're working on our little async web server, baby. Connection allocator goes here. Connection allocator goes here. So what's he mad about now? Expected use size found this, so do I have to write try here? Can I do try in a comp time block like this? I assume so, but I don't actually know. Okay. So now this becomes public here with writer here. Okay, we're getting somewhere. Expected. This thing found that. Because writer's on the other side here. Okay. And then I guess here it should be not this, but we put the shit into the buffer and then we break the block with the buffer afterwards. Okay. Runtime value contains reference to comp time var. Whoa, wait, what's the problem there? Oh, break block, maybe it's this way? No. I thought that this is okay, no? Because now I just have like a fucking thing that's a const u8. That's weird. Am I fucking stupid? Make hold on. What if I do this? I put it in a global structure. I just put this raw into a structure, which means that it has to be evaluated at comp time, and then I don't have to worry about it. It just like kind of comes for free if I do this. Try outside function scope. True. I guess. Okay. And then global response here. Okay. Global variable returns reference to comp time var. Why is that not okay? Why is that not okay? Oh, you need to return the const, not var. Oh, I see. Right, so it's like this bullshit, right? So const final equals buff, return, and final. And now it's a pointer to a comp time constant, not a comp time var. I see. Thank you. Thank you. Cool. I mean, that's pretty sick. Okay. So that's like a lot of this stuff fixed. A lot of it. Now we just have to go through and every time we respond anything, kind of fix it. So respond JSON now takes in connection alloc is the only thing there. And we need to return here. Okay. Return here. Okay. Connection allocator here. Bing, bang, boom. Easy. Easy, easy, easy. Pipe. Okay, we need to return the pollable with connection allocator. Bang, bang, boom. What's scary here is that if we fuck this up, we'll end up on the wrong allocator and things will just kind of work. Actually no. If we restore our allocator here before we start writing, okay, never mind. It'll be fine. We will crash nicely, which is good because I want to crash nicely. Okay. Return here, and then respond empty. He needs the connection alloc as well. Chillin', chillin', chillin'. Okay. Maybe there's like a find replace here I should be doing, huh? Probably, huh? It's like, respond, empty, connection is replaced with respond, empty, connection alloc, connection. Okay. Yeah, can we just do that? I think like the vast majority of this stuff kind of fixes itself that way. I think I had more to do here. Okay, there we go. And then can we do like, okay, if I move, it's fine. Okay, respond JSON with self-scratch allocator is now respond. Hello? Why can't I? Whatever. Respond JSON connection alloc. There we go. And then I also forgot to do like oh, wait. We're getting close. I think all of these guys are gonna get mad because I didn't return. Yeah. So on all of these guys, I gotta go like white space. I guess like beginning of line, white space, try respond is now like Jesus Christ. So this is like we need to like capture this shit. I think that's with these. And then this is like put that thing back, and then do return try respond. Yep. Okay, we're getting close. We're getting close. We're getting close. Okay. One more. Okay. Make? Are we there? Let's go! Okay, so all of these guys are fixed. All of these guys. Now we just need redirect to index. I think we have kind of the same thing that we did in the other thing, where here we have like the respond empty shit. You know, we kind of have like the same shenanigans here, where we have a thing that we're returning, its status, moved permanently, content length 0, headers is location, is index HTML, right? Redirect. Redirect me over there, please. Which I guess means that this all kind of feels like a... It feels like something that should exist in the HTTP library, no? Like, it feels like this is a... Like... It's like, almost like this is... Make... Like, something like this? Comp time params. Am I stupid for naming it this way? Make HTTP header comp time. I feel like that's close. Because I guess otherwise we need like a... It would need to be like make HTTP header buff or something. Which is not quite what I'm looking for. So I guess we'll see. I guess we slap all of this in a comp time block. Params goes away. We have params here. Bing, bang, boom. Params here as well. Okay. Yeah, sure. And then this just becomes make HTTP header comp time with like this? Yeah. Oh yeah. Something's wrong? I don't know what. Feels good to me. Maybe I cut and paste something else here. Yeah, there we go. Yep. And then this should be used somewhere, wherever, like, respond empty as well, right? Yep. Oh, yeah. Oh, yeah. And then, really, we should have, like, a make, write buffers. You know, just get all this all the way too. Yep. So from this allocator and connection, easy. What is this? Stood net connection or something? Stream, probably. Yep. Respond buffers. Respond buffers with alloc connection. Response. There we go. Bang, bang, boom. This is header and response body. And now our custom thing becomes a lot easier here because we can go like, boom, connection alloc here, connection and response. Easy. Okay. Error called at runtime cannot return from comp time. Like this? Is it like we have to do like this bullshit? I think it's like this shit where you have to like break out of the block to return from outside the comp time. You know what I mean? Yeah, we're close. Okay. Headers is a array of constant structs key value. He's like, yo, this thing does not support array initialization. Oh, so this needs to be like a key and value probably. And then this thing needs to be tried, I guess. But I guess, like, technically, can this thing even fail? Like, surely not, right? Because it's a comp time thing? Surely. Surely. Nice. Nice. Okay, we're really getting somewhere. We're really getting somewhere. So, all we have to do now is handle these guys who have, like, custom outputs. I think that error meant you were missing comp time at the call site. Yeah, I mean, kind of. I agree with you that, like, I could have fixed it by putting comp time at the call site, but I don't want to force myself to put comp time at the call site. This is the same thing, right? Where it's like every instantiation of this function will result in like a new comp time buffer somewhere. And it's like, you know, I could put comp time here to say that I like am using the comp time result, but like I'd rather just have it go inside. I guess you're saying by making it inline, like it will do that for you. Yeah, I guess that might be better. I don't know. Not sure. Not sure. Okay. Let's take a look at this memory usage thing. So what's this guy doing? He's like, let me create some content. So I guess the answer here is that we want respond buffers at the end here somehow. We're definitely making a header here. So this becomes like make HTTP header with connection allocator. Okay. With all of this stuff. Okay. Then we have the response buff is the body. So this stuff now comes from the connection allocator. From buff. Why are we doing it this way? This is stupid. So connection alloc, we were saying that the maximum size here is 8K. So we unconditionally allocate 8K here. Fine. That's fine by me. This stuff is on the scratch allocator. This is not actually going out to the output, so that's okay. This stuff can stay on the scratch allocator. And then we just say like respond buffers with connection allocator connection and header and response buff. Sure. Sure, fuck it. No writer on this guy? Yes, there is. Whoa, what the fuck? Expected type const found type info function return type error union set. Whoa. Oh, I just forgot to write try here. That's why. That's why. What's he about now? Oh, here I have to write try as well. Nice. Okay. So let's just check if that's working. So it's localhost 990 with memory usage probably unimplemented. Is it the wrong URL? It's just memory. We should fucking use the same names. It's crazy to... Okay, cool. And the good news here also is that it looks like this is stable, so like we're not leaking memory through this pollable thing that we're doing, which is good. Which is good. Okay, cool. All right, a couple more things to do. So it's just these like file writers, which we would want to like not have to load the whole file into memory at once and do like send file or something. But we don't have to do that yet, which is kind of hype, right? We can kind of get away with just doing what we were doing before. Read the whole thing into memory and respond with, you know, this shit. So content length now is content len. Content type is content type. Easy. Fuck this writer then. And then we just want content here. Now, we have a problem here where the content is loaded into scratch memory, which is wrong. This needs to be like on the connection allocator. So wasm dir read file alloc options. So the problem with this like read file alloc is that if I remember correctly, inside this thing it uses an array list, and that wastes a little bit of memory if we're using like an arena allocator here. But I'm just gonna not care for now. It's the easiest fix. It's the easiest fix for now. Okay, cool. And then we can kind of do the same thing for file system here, where we find the target end, we create a buffer here, so fuck all of this, and this just becomes read file alloc on the connection allocator. And then we respond with respond buffers. Oopsies. There we go. All right. That's a maybe. What's our max size here? 10 megs? Fuck it. Okay. So now, like, everything should be working now, right? We should be able to go here. We should be able to go... Oh, here's the really good news. After all of that shit, our website works again, right? We're succeeding to load these, like, mega big, 1 megabyte WASM files, which are only 1 megabyte because they're full of debug info. But yeah, looking good. I think fsdir read file alloc is smarter, right? I think that's what I'm doing. fsdir, this is no array list. I think resource-dir here is an fsdir. If I jump into this, into read file alloc, he does read file alloc options. This turns into... open file. If the file doesn't have a fitting use size, it'll certainly agree with greater than max bytes. So he does get a size hint here, but the size hint is null, so there's no size hint. He goes into here. size is 0. The file returned by stat here is used as a hint to set the buffer. Ooh, hold on. If size is greater than 0, size else 1024 max bytes. Yeah, I don't see any stat. I don't see anywhere where he calls stat here, no? Oh, get endpause here. Ah, okay, so if there is no size hint, then he chose file get endpause. So there is an array list in here, but he should be reading it with the size hint from stat, which means that like most of the time it won't overallocate. But there is still an array list in there for if he gets it wrong. No, I mean I misread too, right? You're saying I guess like I didn't realize I missed this piece here. I didn't see this the last time I looked. But either way, yeah, it's not like this takes a different path if that. And then also, if we're doing to own slice, is he smart enough to like not reallocate if he doesn't have to? He tries to do a remap, which might be free. Maybe. It might work. Might not. It might double up. But whatever. Whatever. Okay. So yeah. I think that worked. And I think that's probably a good time to call it for now. Let's go back and look at like what actually happened. So we refactored our HTTP connection so that this serve function that is called by like the generic HTTP connection interface returns no longer just tries to write to the output, but he returns a pollable thing. Pollable is a thing that has poll and finish, right? And we implemented a pollable for just like sticking out like a chunk of buffers, right? So we allocate some buffers and we say, hey, write them if you can, right? Just like write as much as you can. If you can't right now, we'll cover the rest later. Then in our HTTP connection, we expect now that the serve function of this guy returns one of these pollables and immediately calls poll write, where poll write just polls the inner handler. Bing, bang, boom. Everything's pretty happy. This guy could put the connection in here so that the inner guy doesn't have to hold the same file descriptor again, but it's like whatever. Yeah, I think that works pretty well. And then we could eventually fix the fact that we have to read really big files into memory. That all like comes almost for free here, where our serve function that could just return like a different pollable. Yeah, okay. Cool. I apologize, it's not really very visual, right? So like the end of this is just like it looks like the same as it looked before. But I'd say that's a success. I don't really have much else I want to do today, so I think we call it there. Oh, speaking about async in general, did you get a chance to play with IO Ring in one of your streams? It's been on the list for like 2 years. Like basically that was like the first, like the very first project we worked on was writing an operating system, and I wanted to learn IOU Ring as like inspiration for some of the interfaces in IOU Ring, or sorry, for the interfaces in my operating system, and we just never got there. But it's been on the list of things that I want to do for a really long time. So maybe one day. Okay, thanks for watching, guys. If you like what you saw, we stream most days. We're for 12:30 to 4 o'clock Pacific time. It's 3 now, so we're ending a little early. But you know, if you're watching live, anywhere from 2.5 hours ago to an hour from now is when you should expect to see us. If you want to keep up with the streams, but you can't watch live every day, there's a YouTube link where like maybe half the stuff goes up. Stuff like what you're seeing today goes on the YouTube. Stuff that is hard for me to title and thumbnail in a way that will get clicks basically does not. So things like cleanup, research, like just kind of scattered, you know, assorted fixes, stuff like that goes in the separate section where it goes up on Patreon, Twitch, or on YouTube members. We do it that way so that, you know, we don't like tank the YouTube algorithm. And then also we have something to like provide to people who want to support the stream. So the stream will end when I run out of money, right? So if you want to make sure that the stream lives for longer, please consider supporting. You get back VOD access to the rest of the stuff that doesn't go on the YouTube. I think that's all. We don't have to plug much more. YouTube, peace out, and Twitch, let's find someone to raid.